Here's how the Owon came packaged, basically. It's double boxed, although it's not really a hefty 2 boxes. But adequate, I think. Outer box, inner box. Cute little box for display, although it's kind of funny. It's a kind of box that was developed for any of the scopes. So it says bandwidth 60 megahertz to 300 megahertz. So if you saw this sitting on a shelf in a shop, you might think, wow, it goes to 300 megahertz. Instead of the fact that they're talking about the entire line. So inside the box, that's what it looks like. Well, fairly protected. You've got the standard USB power cord and the scope. Little booklet. I already took the probes out. They were in here along with the disc and the manual, an actual printed manual, although the manual again looks like something we all were cranking out on our laser printers 15 years ago. But anyway, there is an actual printed manual. Scope itself, there we go. Now the scope did come with a piece of plastic on here, which I peeled off, so there was a protection on the display. It also came with these little B and C covers, which I popped off the 2-channel inputs, but I've left on the external trigger. So here are the probes that came with the Owon scope. As I mentioned in my post on EEV blog, I'm going to be comparing this to the Rigol, or is it Rigol? I have no idea. DS1052E because, well, for 2 reasons. That's the only other DSO I've ever owned, and I just had one for a month testing it out and returned it to go for this. It's not completely fair since this costs about 18% more than the Rigol, but since it's the only thing I can compare it against, that's what I'm doing. I don't have the Rigol anymore, so I can't compare it directly, but right off the bat, these probes feel much nicer than the Rigol ones. They feel heftier. The compensation adjustment is here as opposed to, I believe on the Rigol it was on the handle. Instead it's on the actual jack itself. And the main thing, I guess, is one thing that was driving me crazy with the Rigol was that the little 10x 1x switch was really easy to throw. And I was constantly knocking it to the wrong setting and not realizing it later till I was measuring. And this one is very solid, has a nice click, and it won't be easy to do that with. The wire feels heftier. They just feel better and more solid in pretty much every respect. I mean, the various attachments you get are the same, of course, and these are rated for 100 megahertz as opposed to the Rigols, which I believe are 60. So basically I wanted to look at the build quality of this in this section of the review. I actually was surprised. It's a bit better than I was expecting after things I'd read about the Owon other products online. The layout is more or less standard in a lot of other DSOs. I am a big fan of the separate vertical controls for the 2 channels, as opposed to the Rigol. It had just one set of vertical controls and you had to constantly swap to get on the right channel, and you often forgot and you tended to move the wrong channel. I'm not a big fan of having the trigger menu button here and the knob here as opposed to the other way around to keep them in line, but I suppose some companies do that to keep it separate from the horizontal and vertical position controls for the channels. Other than that, the layout is rather standard, although this has basically 2 rows of menu keys, which we'll get into more when we start looking at the firmware. This is real handy for some things and a pain in the ass for the others, but again, I'll get into the strengths and weaknesses of that later. As noted before in another online review, there seems to be a little IR LED here, as if they're thinking about the possibility of making remote controllers for these devices. I'm not quite sure how that'd be used, but anyway, that's sitting there. Other than that, the front is, you know, rather unremarkable, except for the fact of that giant 8-inch display, which, by the way, does have anti-glare coating on it, which is great. I mean, the display in general is very beautiful, both off and on. Now, going around the side, let's look at the various connectors and whatnot. Here you see this empty LAN port for the LAN, which Owon was advertising online is coming with these models, but they haven't managed to implement it yet, so it's not here. This is labeled as COM/monitor, but it looks like a standard SVGA or VGA, connector to me, so I'm not sure how you get RS-232 signals out on it. I haven't seen any data that would explain that yet, or if that's possible. We'll get into the VGA output later when we start looking at the firmware again. It has the typical host and device USB connectors here. The other side has the AC power in. It has a little fuse holder and pop out, and it has the master power switch. There's another power switch on top. The reason I guess they've divided it is if you have the battery installed, you can have it turned on and charging the battery, but keep the display and the rest of the unit turned off. The battery compartment is here. I have not bought the optional battery yet, although that is a great feature to have, and it's one of the reasons I was interested in this. One obvious design flaw here is that this thing weighs, it has a very good heft to it for the size. It feels good, a good weight for its size. It's heavy enough to not float around too much, but not too light that it feels somehow cheaply made. But adding the battery obviously is going to add weight to it. So clearly, if you do have a battery, sometimes you want to use it and sometimes you don't. If you're going to an on-site job where there's plenty of AC available and you don't have to worry about the battery, you might want to leave it out just to leave out the weight of carrying it. But the battery compartment itself is attached with very long screws. So here's the battery compartment with the screws loosened and the block being taken out. This obviously is just a kind of insert when there's no battery there. Battery does not go inside it. I'm not sure, since I don't have a battery, I assume it attaches the same way with two screws that go in these holes. Personally, just in terms of speed and swapping to battery usage and not, I probably would have preferred some kind of clip there as opposed to screws. But perhaps for over time, the screws are more reliable. So the back has only the pass-fail trigger output and a ground lug here. I'm not a big fan of the connectors on the sides of devices as opposed to the back. I guess I understand from a design point of view the reason Owon did it was because obviously the main PCB in this is mounted parallel to the front panel as opposed to perpendicular. So I suppose that's the reasoning. I'm not a huge fan, like I said, but maybe it's a small price to pay for the thin size, I'm not sure. Again, it feels quite solidly made. It feels, there's no flex in the unit at all. Feels well built for the most part. It does, by the way, have a fan inside. Probably a lot of people were wondering about that. The fan is very quiet, as it should be. The Rigol had a horrible fan, and that alone was one reason I was constantly thinking about getting rid of it. It really was, I've got 3 computers running here, and that Rigol fan was louder than all 3 combined. I'm not sure if that comes through at all. It is really whisper quiet. You don't know there's a fan there unless you put your ear right up to the thing or feel a small amount of air moving out of it. We can look better at the knobs because I wanted to go over these a little bit. Generally speaking, they feel reasonably okay. The smaller turn knobs here feel a little bit iffy. And I've noticed when I've been using this for the last few days now, that I sometimes hear a little noise as if these things are already starting to, run into ever so slight problems. So I'm not sure about those. What's interesting, one thing that's interesting is that all of the knobs on here are clearly knobs that have switches installed, although they're only using the switches on those 5 knobs and not the larger ones, which is a shame because they don't have the coarse and fine control for vertical and horizontal position as Rigol does. And that I kind of miss already. There's just a coarse control and nothing else. These knobs, the menu select knobs, sorry, buttons I should say, you know, you can tell from the sound of them. I mean, there are these little cheapo membrane switches that anyone who's, you know, made any PCBs is, you know, are well aware of. Generally, it's okay, but you'll notice, first of all, these are all mounted on a separate PCB, which is slightly floating there. So if I hope that camera picks that up, if I wobble this a little bit, you see them all wobbling. So that's a little kind of shoddy looking. But, you know, more so than that, they've got it mounted so close to the display in such a way that when you're clicking them sometimes, you're causing a little bit of a disruption to the LCD display. Let's see if we get that. You see that? Some kind of close mounting right there at the edge is causing disruption, which I don't think should really happen. Again, clicking there, I'm getting a little bit of wobble in the display there. The other thing, hang on, this obviously has the feet which tilt the display. The other thing, because some of the knobs and buttons are so stiff, on a slightly slippery desktop like this, pushing them, these are not a problem because of the angle they're mounted at, and they're near the bottom where the rubber feet are. But for example, these, I can't click them without shoving the display around. Same with the push knobs on here. So you have to come in with a hand behind to switch these. That's not a big deal, but you know, still, they're maybe a little stiffer than they ought to be for perfect usability. So now we're booted up, ready to display waveforms. The display is 800 by 600 pixels. Just as a comparison to the Rigol screen, I cut a little piece of paper to indicate the size, so this will give a better idea of what's going on here. You can see there's quite a lot of extra screen real estate on the Owon compared to the Rigol. So let's take a look at the menu system in the Owon. Whenever you press a button which generates a menu, meaning these two vertical menus, the horizontal menu, trigger, or any of the function keys, the Owon produces a menu, the first of sometimes 3 menus, down here in this section of the screen. So for example, if I take measure, I get the menu down here with the selections add or remove. Let's say I choose add. The second menu or the sub-menu will pop up here on the right side of the screen. Sometimes one of these buttons will generate yet a third sub-menu. For example, if I select type for the type of measurement I want to add, the third menu will appear here on the left side of the screen. Whenever the left side menu appears, it means you can scroll through it with the multi-purpose knob, for example. Now, I understand from a design point of view why Owon did it this way. At least I think I do. I'm guessing it's 2 reasons. One is, of course, they keep the screen clear in the middle as much as possible for the displayed waveform. And secondly, having the first menu appear down here, and this menu down here is always there unless you've selected a different menu. This is only used for menu display. But having it appear down here gives you the option of being able to change some things without having to invoke a menu button again. For example, if I have the trigger menu on and I've got a waveform up and I'm changing the settings to display the waveform, I can select and change trigger options while I'm doing that, but without having to go back to the trigger menu button. There's 3 little kinks or faults with this system that aren't completely ironed out, let's say, from my point of view, which I'll briefly describe. The first is, because you sometimes have 3 menus, so you have the first menu here, second, third, your hand does this a lot. Up here, down here, back over to here. Now, ergonomically speaking, this movement back and forth isn't the brightest. So personally, from my point of view, even though I do like some menus appearing here and remaining here, I wouldn't mind having some of the menus, which have perhaps only one sub-menu, starting here as opposed to here. But maybe that would be confusing for some users because some menu buttons would produce the first menu here, some here. But that's just my own feeling about it. Secondly, this area of the screen is only reserved for the menu display, and that's a little bit of a shame. It would be nice to have the option of turning that off and using that area of the screen for more of these measurements. So that's a second little fault I see with the system. The third is that the idea of this being permanently displayed while you're doing other things with the waveform is great, but it's not well implemented. For example, if I select the trigger menu, I have these options for type of trigger, source, coupling, the slope, and then sweep options. You'll notice down here, well, maybe you can't see in the video, but for example, for slope, you've got, positive and negative edges. And by pressing this button, I can just alter between the two. And if the trigger menu's up while I'm looking at a waveform, I can do that without having to go back to the menu buttons. But Owon has seen fit to only allow this toggling of options when there's only two. If, for example, I want to change the coupling of the trigger, I click here, I get the second menu again with 4 options. And then, let's say I've got the high frequency filter on, and I want to go back to AC coupling. I have to click that and then come back up here again. Personally, for things with, say, 3 or 4 options, I would rather just go 1, 2, 3 and get to that option as opposed to clicking this and bringing my hand back up here again. So I think that could be implemented a little better so that you could just toggle through your various options here without having to go to another menu and cluttering the screen up. Let's take a look at the display of data on the Owon screen. You've got down here in the bottom right corner, just above the menu line, the type of trigger and the trigger level. Here towards the center of the screen, you've got the seconds per division you're set at. Across here over in the bottom left-hand corner, you've got the data for the 2 channels, including the volts per division, the coupling, as well as the level. Next to that, you've got something that's very nice. You've got the sampling speed and the depth set. And you can see as I change the seconds per division, that alter. So you always know exactly what speed you're sampling at. Below that area, you've got an area for user-defined measurements. Now, this was one of the frustrating things about the Owon to me when I first started using it. I thought, well, I can only fit in 4 measurements, which doesn't feel like enough for me, especially when you consider the large screen. And of course, I didn't read the manual. Later, I discovered, while reading the manual, that in fact, more than 4 fit. I'll show you what happens when you start to add extras. So we'll come in here and just start sticking some more in. There's a 3rd, there's a 4th. Now you think, I thought it was like the Rigel, if I add any more than 4, it'll pop the first one out and the new one will take its place or move to the bottom of the list. Instead, what happens is this. Strangely, it pops the channel data and the sample rate and depth outside of that area and makes room for 4 more measurements. So that means you can have up to 8 user measurements on the real-time measurements on the screen at a time, which I think is enough for most usage. I think the biggest failing of the Owon firmware is that they have yet to take advantage of this great big screen they've installed in these models. As I mentioned before, this portion of the screen can only be used for menus. There's no way to turn that off. They only have coarse control for the volts per division adjustment, so you can't maximize the wave to fill the screen entirely. And they also don't use dual window mode for anything, so you can't use it for FFT and you can't have the waveform record here and a zoomed in portion here. They haven't implemented dual windows yet, which seems a real shame on such a large display. I wanted to talk a little bit about some of the features I do like about the Owon apart from its screen size, and one of those things is the amount of memory it has for samples. You can see down here right now I have the sample depth set to 1K, but you can change that length between 1K, 10K, 100K, 1 meg, and up to 10 meg, which is kind of amazing. I'm going to put that on 10 meg right now. Now the scope is reporting it's going to sample at 1 gigasamples a second with a depth of 10 megapoints. So I'm going to trigger a single sweep of some digital noise. Now we're going to zoom out, and if my math is correct, we should end up with a record length of 10 milliseconds. And you see when we get to the 5 milliseconds per division that it's 2 divisions long, so it's 10 milliseconds. I've now got both channels enabled, and you can see that the sample speed is at 500 megasamples a second. That means the ADCs are running non-interleaved at the moment. I'll get into that more when I start talking about the insides of the Owon in the final part of this review. But right now I'm going to trigger another sweep. Now as I zoom out, you can see the Owon has an astounding 10 milliseconds pre-trigger information here because of the massive 10 megabytes of memory. Both the Owon and the Rigel allow you to record waveforms up to 1,000 frames at up to 1,000 seconds apart. Obviously, the Owon with its 10 megabytes of memory is going to allow much more detail in that waveform recording. Also, as far as I know, the Owon is the only one that allows you to take that waveform record and play it back through the pass-fail output, which is really a nice feature. Another nice feature that the Owon has that the Rigel is missing is that when you use pass-fail, you can use as input to the rule for source not only channel 1 or channel 2, but also math of the two channels combined, and that's very nice. Another good idea from Owon is that the output at the back, which is normally reserved for pass-fail, can be switched actually so that it's either the pass-fail output or it's a synchronous trigger level output. So that means that you can trigger the scope and the trigger can pass through to other devices. So I happen to have the output at the back fed back into channel 2 here, which we're going to turn on. You'll notice as I expand the time base that the trigger out is delayed by about 1.25 microseconds from the trigger in. Also notice the curve in the waveform here. The trigger out is optically isolated, and I don't have it pulled higher or anything. I'm just running it directly into channel 2, so that's why you've got this curve on the waveform instead of a nice sharp edge. But this is a handy little feature. You can see as I zoom out on the waveform that the trigger signal goes high, the trigger in stays high for the rest of the sweep. The last feature I wanted to mention about the Owon, which I think is really great, is the VGA output. Down here you can turn it on or off. Now you may wonder, with such a large screen, why would anyone ever need VGA output? Well, I can think of two good reasons for it. You might be doing something over here which is causing your scope over there to be triggered, and it's nice to be able to see the waveform from a distance. Now I know you could just record the waveforms and then play them back later, but A, that isn't real time, and B, it means walking back and forth. Or secondly, you might be doing something at your computer that's related to the measurements you're making, such as running logic analyzer software or something, in which case it's not that handy to have to keep looking away from the computer screen to check the oscilloscope screen, so it's nice to have all the data directly in front of you. I've got the oscilloscope data up on the second VGA screen, but if I happen to have one of those cheap $15 VGA to video converters, I could just run it directly into the larger screen and use the picture-in-picture and have it displayed here, and I wouldn't need the second screen. As I started to try to use one of the features of the Owon, I started running into some problems. The BNC output on the back of the Owon is listed as a pass-fail out or a trigger out. You can select it in the firmware, which one you want to use. And in the owner's manual for the Owon, it says that this trigger out is optically isolated and it's a synchronous trigger out. But actually neither of those two things is true. First of all, you can see right away that the output is not optically isolated by just using a continuity check between the ground on one of the front panel BNCs and the ground here on the back. and you'll see that they are connected. So it is not optically isolated as Owon claims in the manual. That's less of a problem for me than the fact that it's not really a synchronous trigger. And you can see that real easily by, I'm taking the trigger out from here and I'll run it into channel 2. I now have the trigger output running back into channel 2, and I'm using alternate triggers, so each channel is triggering itself. This is a 1 megahertz sine wave on channel 1, and then the trigger out on channel 2. And now, when you have a signal coming in that's regular, that's triggering, so that the sweeps are regular, the trigger out should actually be a factor of the horizontal time-based setting. In other words, you should be able to work out the frequency based on the time-based setting for every scan that comes across. But in fact, that's not what's happening at all. It's, as you can see from the frequency counters here, it's counting right now at about 23 hertz. So it's actually outputting a pulse 23 times a second, which is much less than it should be in terms of the time-based setting. So it is not actually working correctly. If you look at other scopes that have trigger outs as it should be. It does work to the extent that if you have slow, irregular triggers coming in on channel 1, it will output a trigger out at the back, delayed by 1.5 milliseconds or so. But it does not output a correct synchronous trigger if you're triggering input to channel 1 is much faster. The other thing I discovered when I started doing this was that I realized by doing this that I could actually see what the screen refresh rates were. You can see the frequency of the trigger out coming back in, and that's indicating the screen refresh rate. And as it turns out, that's indicating the waveform capture rate of the Owon, because it appears the Owon works as a traditional DSO in that it captures a wave and writes the screen, captures a wave, writes the screen. It doesn't do any kind of DPO-like processing on the data. So you can see very clearly by changing settings. For example, we're using 1K memory depth now, but if I change the acquire length to 10 megs, you see now the screen refresh rate has dropped down to something around 14, well, it's around 16.5 hertz right now. So going from 1K memory to 10 meg memory has dropped the refresh rate from 23 down to about 16, which isn't bad considering the factors involved. So you can test all kinds of things to see how they affect your refresh rate by using this trigger out. For example, if I turn persistence on now, you'll see what happens again to the rate. So I go to 1 second persistence and the rate has now dropped down to around 6.5 hertz. You can see by altering the setting between infinity, 5 second, 2 second, 1 second, it's altering the refresh rate of the display. And in essence, it's altering your waveform capture rate as well, which, as it turns out on the Owon, is very slow. The Owon only captures waveforms and displays and puts them on the display from anywhere between approximately 1 to 25 per second, which is not a great rate. The one thing I can say about it is that when the 10 meg is enabled, that rate is something between 1 and perhaps 16, 18 waveform captures a second, and that's quite good for that amount of memory. So what they appear to have done with the Owon is, instead of giving you the slow rate when you're using the 10 meg and a much faster rate when you're using 1K or perhaps 10K, they've decided to even it out so that all the rates are not that far apart from each other. You don't notice a massive difference in speed as you would really expect when you go from 1K to 10 meg capture depth. And I understand that was a design decision to make. It's a little bit of a shame. Personally, I think I probably would have decided to keep the Owon if they had decided to make a very fast waveform, or the fastest possible waveform capture rate they could have with the very low memory settings, the 1K or the 10K, maybe just 1K is fine for a fast waveform update. and then gone with the slower DSO qualities of capturing writing, only when used the higher memory settings. After I discovered the slow waveform capture rate of the Owon, I decided to run some tests to see how that might affect hunting down glitches. So I created a square wave output that had one irregular pulse, one glitch per second. And then I used the pass-fail function of the Handtech to try to capture that glitch. In other words, to make it fail when that glitch happened. One thing to note is that on the Owon, it can do about 12 pass-fail tests per second. That has to do with the fact that it has a larger screen size and, of course, the slowness of its waveform capturing. For example, the Rigel can do about 30 per second, but this can only do about 12 per second. So it's doing 12 tests per second. At first, I tried to use the 20 microsecond time-based setting, and I was making sure that I was sampling at 1 gigasamples per second. And at that horizontal setting, it took it about 100 minutes to capture the fault, in other words, to fail. So it was a glitch that was happening once per second, but it took it 100 minutes to find it. Next, I went to the 1 microsecond time-based setting, and at that setting, it took it 8 hours to capture a glitch that was happening once per second. So you can see that the Owon is not a good scope to buy if your main concerns are signal fidelity or hunting and capturing random glitches. It's going to have a problem with that. All in all, I think the Owon is a nicely designed, well-built scope. It definitely has that look and feel of a Western product about it, as opposed to some of the other cheap Chinese oscilloscopes that are floating around. But in my opinion, the firmware is still underdeveloped or lacking some features that would make it more usable. Still, you do get a lot of bang for the buck, and I can imagine that there are certain scenarios which would make it worthwhile to purchase the Owon. If you absolutely need a cheap DSO with either a VGA out or a trigger out, which you can only use the trigger out if your trigger in is happening at a slower rate than the refresh rate of the display. But in either of those cases, if you need a cheap DSO with one of those two things, the Owon is really the only one around, as far as I know, that has those. So if one of those things is absolutely a necessity for you and you don't have much money to spend, the Owon's worth getting. A second reason you might get it is if you need a cheap DSO that's battery operated but has a large screen. Again, the Owon, as far as I know, is the only one in that class with that ability. The third reason you might go for the Owon is if you need a cheap DSO that has very deep memory. It has 10 megapoints of memory per channel. So if you need a cheap DSO that, for example, for single shot waveform inspection, again, the Owon is the only game in town. The last reason why I could imagine that you might buy an Owon is if you needed a quick, cheap DSO, but you are planning to upgrade later and get a more expensive one, such as the GW Instec or one of the Agilent, it might make sense to buy the Owon now, and then later, once you have your nicer, faster bench scope that you can use, you can keep using the Owon as a portable with the battery for field work.